Hey everybody, John here. We are going to prove the basic cofunction identities. And again, these are on your formula sheet that is posted in part 4 of the Blackboard folder for course content. And this formula sheet is something that is normally given on the exam. It's attached to the exam, which it still will be attached to the exam that you get. But you have access to your notes because you're at home, so I don't have to give you this sheet. You have all of the formulas that you could want at your fingertips. So let's go ahead and start with the difference formula for cosine. So I told you that we proved the distance formula the difference formula for cosine. We used the distance formula to prove that. And I just want you to know that every single identity that is on that page comes from the difference formula for cosine. So let's start with cosine of u minus v, which we know is cosine u cosine v plus sine u sine v. Again, you don't have to memorize this because it's given. If we were going to be giving this exam in class, I wouldn't make you memorize it either. I would just make you memorize the Pythagorean identities and the definitions, like tangent is sine over cosine and secant is 1 over cosine, those kinds of things. So I'm actually going to substitute in pi over 2 for u in this formula. So that gives me cosine of pi over 2 minus v is equal to cosine of pi over 2 cosine of v plus sine of pi over 2 sine of v. And as we saw in the last example, cosine of pi over 2 is 0, so this whole thing goes away, and we're just left with sine of pi over 2 sine of v. But sine of pi over 2 is 1. And so this just becomes 1, and we're left with sine of v. So cosine of pi over 2 minus v is equal to sine of v. And this is our basic cofunction identity. The other one comes from keeping this formula right here, and I'm actually just going to substitute pi over 2 minus v in for v, which sounds kind of strange, but if we let v equal pi over 2 minus v in this formula, we get cosine of pi over 2 minus pi over 2 minus v, and that's going to equal sine of v is now pi over 2 minus v. And so pi over 2 minus pi over 2 gives me 0, and negative minus v gives me a positive, so this becomes cosine of v equals sine of pi over 2 minus v, and there's my second cofunction identity. So these are my two cofunction identities. There's one there, there's the one there, and you can actually see those written out right there. So that's where those came from. And notice they both came from the difference formula for cosine and then a little bit of algebraic manipulation. So we're going to use this to prove that for any real number, tangent of pi over 2 minus x is equal to cotangent of x. So this is another cofunction identity, and we're going to prove this. So I'm going to start with the more complicated side, which is the left side here. So this is an identity, and I'm just showing that it's true. I'm starting with the left side, and starting with the more complicated side, tangent is equal to sine over cosine. Okay. Now using the cofunction identity that we just figured out, these two right here, sine of pi over 2 minus x, that's just cosine. And cosine of pi over 2 minus x, that's just sine of x. And then cosine over sine is cotangent of x, and I have proved my identity. Okay. And I would like to take this opportunity, I didn't say it in the last videos for the last lecture, but when you're doing an identity proof, it's important that if you do get stuck, you just stop and you say, I got stuck, and write down, I got stuck. If you are doing algebraic stuff that looks good and you get stuck, that's okay. But if you're doing algebraic stuff that looks good and then you get stuck and then you just write down the final answer, like you skip a bunch of steps and just get to the final answer without showing the work behind it, you're not going to get a lot of partial credit. I'd rather see that you knew that you were stuck and you couldn't get to the answer, but you tried some strategies. That you'll get credit for. But if you try to then just show me that you've gotten the answer when you haven't actually gotten the answer, I'm not going to give you much partial credit for that, if any. So just be aware. All right, so in the next video, we're going to prove the sum and difference formulas for sine, and then we'll do some examples using the sum and difference formulas for sine. So I'll see you in the next